All right, for example 1, using Trig, Katrina needs to build a ramp for a wheelchair access to a house. The height of the ramp needs to be 4 feet, and the ramp must rise at an angle of elevation of 23 degrees. How long must Katrina make the ramp to meet these specifications? So for this one, we got a ramp. The height of the ramp needs to be 4 feet. And then the angle of elevation is 23 degrees. So again, angle of elevation is horizontal to that 90 degrees. We got 23 degrees there. And then how long must Katrina make the ramp? So our ramp is our slanted side, so that's our X. So for this one, we're going to highlight the angle given to us. We got our opposite and our hypotenuse here. So if we grab SOHCAHTOA, opposite hypotenuse goes with sine. So I'm going to set this up as sine of my angle equals my opposite over my hypotenuse. Now here I'm missing a side length, so I'm going to multiply by my denominator just like I did in the last unit. So multiply by x, multiply by x. Then I get x sine 23 equals 4. I need to get that x by itself so I can divide out the sine 23. And then we're going to enter that into our calculator. So we're going to grab 4 divided by sine 23. 4 divided by sine 23. And we get 10.2. So our x is 10.2. And then that would be feet. Next one, Abu is a lighthouse keep and spots a ship in the distance. If the lighthouse is 65 feet tall, and he looks down at the ship at an angle of angle depression of 37 degrees. Again, the angle of depression is horizontal to my 90 degrees. How far away is the ship from the shore? Ship from the shore. So that's x. So again, we got our angle here. Opposite of that angle is going to be 65. This x is now adjacent. So if I have O and A go with T for tan. So I'm going to do tan of my angle equals my opposite over my adjacent. So this one, again, we have an x in our denominator. So we're basically going to do the same exact thing we just did. Multiply by x. We get x tan 37 equals 65. And then divide by tan 37. So then we get x equals 65 divided by tan 37. And that's going to be 86.3. Or not degrees. It's not an angle. 86.3 feet. There you go. Okay, next one. Shayna is 5 feet 3 inches tall and is standing 15 feet from the base of the tree when she sees a woodpecker at the top of the tree. The bird is at an angle of elevation of 70 degrees below Shayna's line of sight. What is the height of the tree? So for this one, we have a situation here. So we have Shayna, and she's 5 feet 3 inches and is standing 15 feet from the base of a tree when she sees a woodpecker at the top of the tree. The bird is at an angle of elevation of 70 degrees above Shayna's line of sight. So you got a bird over here. Shayna's line of sight is like here. Okay, so we got an angle of elevation, so this is still 15, of 70 degrees. What is the height of the tree? So what I can do right now is find this height and then add the 5 feet 3 inches after the fact. So let's go ahead and do that. So we got our 70 degrees here, and then opposite of that 70 is going to be my x. This 15 is still my ground, so that's adjacent. So O and A go with tan. So we're going to set this up as tan of my degree 70 equals my opposite over my adjacent. So we're going to multiply by 15 here. Multiply by 15, multiply by my denominator. So then we get 15 tan 70 equals X. Punch that into my calculator. So 15 tan 70, we get 41.2. So our X is 41.2 feet. And I still have to add the 5 feet 3 inches. So then if I add 5 feet 3 inches to that, you can convert the inches into feet too. So there's 12 inches in a foot. So that's going to be like 5 3/12. Oops, 3/12. And if you're not sure what 3/12 is, 3 divided by 12 is 0.25. So 5.25 is what we got. So we got 41.2 plus 5.25, and that's going to be 46.45 feet. And that would be our answer. And then last one, a plane is 3 miles above the ground. So here's a plane. We're 3 miles above the ground. The pilot sights airport A at an angle of depression of 15 degrees, and he sees the house at an angle of 32 degrees. What is the ground distance between the pilot's house and the airport? So for this one, I think we did something similar a little bit ago, but we have basically a house and an airport. So this is 15 degrees. This is 32 degrees. I want to find the distance from the house to the airport. But this triangle over here isn't a right triangle, so I can't just do that triangle. Instead, what I'm going to have to do is use my 2 right triangles and kind of subtract our ground answers. So first thing I'm going to do is I'm going to find, we'll say this is my, oops, I don't want a highlighter here. We'll say this is my X. And then this whole distance here is going to be my Y after. So for my X, I got opposite, adjacent. So opposite adjacent is tan. So I got tan of my angle 32 equals opposite over adjacent. So we can multiply by X. Multiply by X over here. We get X tan 32 equals 3. And then divide by tan 32. Divide by tan 32. And we get X equals 3 divided by tan 32. Which let's see what that is. So 4.8. And then for my Y's, we can do the same thing. Now for my Y's, I'm still going to deal with this 15, this 15 over here. And then again, I got my opposite, which is all the way across over here to my 3. And now my adjacent is going to be the Y because that covers my whole distance. So I got tan of 15 equals my opposite over my adjacent Y. So again, we would just multiply by that denominator, multiply by Y, multiply by Y. I get Y tan of 15 equals 3. Divide by tan 15. Divide by tan 15. I get Y equals 3 divided by tan 15, which equals 11.2. So then what we're going to do is take our y value minus our x value to find just this portion over here, which is what we're looking for. So 11.2 minus 4.8 gives us 6.4. So 6.4 miles would be our answer.